In 1933, a laborer working on a bridge foundation in Harbin, China, discovered a nearly complete human skull buried in the riverbank mud. It was massive, far larger than any modern skull, and perfectly preserved by the river sediment. At the time, the region was under the control of occupying Japanese forces. The laborer, realizing the military would likely seize any significant cultural find, decided to smuggle the artifact out of the construction zone in secret. He wrapped a fossil and lowered it into an abandoned well, where it remained hidden for 85 years. It wasn't until 2018, while on his deathbed, that he finally told his grandchildren where he had buried the treasure. When the family finally recovered the skull and handed it to scientists, that single act of wartime defiance triggered a data-driven revision of how we understand our own origins. When the skull reached modern laboratories, paleoanthropologists found themselves staring at a specimen that defied their existing categories. On one hand, the cranium was large enough to hold a brain comparable in size to our own, paired with a relatively flat face, traits typically reserved for modern humans. But those modern proportions were encased in a heavy, archaic structure. It featured hyper-thick brow ridges, a wide mouth, and oversized teeth that suggested a much older lineage. This specific mixture made it impossible to classify. It shared the brain capacity of Homo sapiens, but its skeletal architecture was too robust to be one of us, yet too advanced to be a simple Homo erectus. It belonged to a confusing window of time known as the muddle in the middle. This era of the Middle Pleistocene is a period where the fossil record is so varied and fragmented that scientists have struggled for decades to draw a clear family tree. Identifying exactly where this skull fit became the primary objective for researchers looking to bridge the gap between ancient ancestors and modern humans. Researchers began by dating the skull to at least 146,000 years ago using geochemical analysis. They built a computational model comparing 600 data points from the skull against 100 other fossil specimens. The modeling revealed the Harbin skull represented an entirely new species, Homo longi, or dragon man. The study suggested that this lineage, which likely includes the mysterious Denisovans, is actually a closer relative to modern humans than the Neanderthals are. To prove this new relationship, the team needed to find much older evidence. They had to determine exactly when the Homo longi branch first separated from the rest of the human family. This led them to a pair of fossils known as the Yunxian skulls. Discovered in central China, these crania are roughly 1 million years old, nearly 7 times older than the dragon man skull. However, 1 million years of geological pressure had left these skulls badly crushed and distorted. Because their true shape was completely hidden by the damage, they had been historically misclassified as Homo erectus. This physical distortion meant that for over 30 years, these fossils remained an evolutionary enigma, their true measurements inaccessible to traditional study. An international team decided to revisit the Yunxian 2 skull using high-resolution CT scanning. This allowed them to map the precise location of every bone fragment and identify the mineral deposits that had filled the cracks. Using virtual reconstruction, the team digitally separated and realigned the fragments. They essentially reversed 1 million years of geological compression in a digital workspace. To prove it wasn't a guess, they ran 10,000 simulations, introducing random errors to verify the shape's consistency. The restored Yunxian 2 skull revealed a surprise. It shared advanced traits with the Harbin skull. This confirmed that the Homo longi lineage, the dragon man group, existed as a distinct branch at least 1 million years ago. By utilizing digital forensics, the team successfully traced the origins of this Denisovan-related lineage much deeper into the past than anyone had previously estimated. This timeline shows the long-standing view. Our lineage split from Neanderthals and Denisovans about 600,000 years ago, but the million-year-old Yunxian 2 skull makes that impossible. If the dragon man lineage was established 1 million years ago, this split happened at least 400,000 years earlier. To verify this, the team used Bayesian tip dating, a statistical method that integrates the skull's physical features with its geological age. The results mathematically place the divergence point at over 1 million years in the past. This shift means that by 1 million years ago, our ancestors were already divided into distinct groups, evolving simultaneously in both Africa and Asia. Human evolution is no longer seen as a simple, straight line out of Africa. Instead, the evidence points to a complex, intermixing web of different populations spanning 2 continents over deep time. This clearer picture of our history only emerged because scientists were finally able to use the Harbin skull as a physical anchor for the Yunxian fossils. It is a reminder that our understanding of the human story can be completely revised by a single bone and by one laborer's decision to keep a secret for 85 years.